Hello everyone. In this video, we'll look at three formal rules for valid categorical syllogisms. Before we see the three formal rules, we need to introduce a new concept. That's the concept of distribution or distributed class term. Here's the definition. A class term in a given categorical generalization is distributed if the generalization says something about every individual member of that class. Let's take an example. The generalization, all cows are grass eaters, says something about every cow. Specifically, it says that every one of them is a grass eater. Therefore, the term cows is a distributed term in this generalization. The same generalization doesn't say anything about every grass eater. For instance, it doesn't say that every single grass eater is a cow. And it doesn't say anything else about every grass eater. Therefore, the term grass eaters is not a distributed term in this generalization. We're going to want to keep our eye on those distributed terms when we're applying the three formal rules. So to do that, we'll always circle the distributed terms. In this generalization, the term cows is distributed, and the term grass eaters isn't. So we'll always circle the first term in an affirmative universal generalization. It's important to keep track of all the distributed terms in our four categorical forms. Our affirmative universal generalization in the upper left corner, all F's or G's, will always have a distributed term in the subject, just like the generalization, all cows are grass eaters. Let's move through the other three categorical forms and see where the distributed terms are. So if we move to the right on the upper row, our E sentence, no F's or G's, we need to know which of those terms is distributed. Let's use an example. No even numbers are odd numbers. If I say no even numbers are odd numbers, have I said something about every single even number? The answer is yes. I've said that it isn't odd. So the subject term of an E sentence is distributed. But think about the predicate term. All even numbers are odd numbers. Have I said something about every odd number? The answer again is yes. I've actually said of every odd number that it isn't even. So the predicate term of our E sentences is also distributed. If we move to the second row where our existential generalizations are, let's look at first the affirmative I sentence, some F's or G's. If I say some cars are red things, have I said anything about every car? The answer is no. I've only said that some of them are red. We also have to ask whether I've said anything about every red thing. The answer again is no. I've said that some red things are cars, some cars are red things, but I haven't said anything about every red thing. So neither term in an I sentence is distributed. Let's move over to the negative existential in the lower right. Some F's are not G's. Suppose I say some cars are not red. Once again, I haven't said anything about every car. I've only said something about some of them, that they're not red. What about the predicate term? Some cars are not red things. Have I said something about every red thing? It may appear that I haven't, but in a kind of a tricky way, I have. Specifically, I've said of every red thing that there is a car that's a distinct object from it. So if I line up all the red things in the world, I can point to the first one and say, there's a car that's different from this red thing. And I move to the next one. There's a car different from that red thing. And the next one, there's a car that's a different thing from that red thing. And I go through the entire set of red things and say, there's a car that's a distinct object. So it seems a little tricky, but it's there. I have said something about every red thing. The predicates of O sentences are distributed. This is a really important table to keep in mind. I very strongly encourage you to copy this square down with your A, E, I, and O sentences where all of the distributed terms are circled. You're going to need that on later slides in this presentation. So I encourage you to hit pause here and copy this down before moving on. There are two ways to remember where the distributed terms are. The first is the rule USNP, Universal Subjects Negative Predicates. So if you look across the top row of this table at our A and E sentences, those are our universal generalizations, you'll notice that the subjects of those generalizations are distributed. And then if you look down the right-hand column of this table, the negative generalizations, you'll see that their predicate terms are distributed. Universal subjects and negative predicates are our distributed terms. A second way to remember the distributed terms is to remember that the opposite corners of this square are contradictories or logical opposites. This is the modern square of opposition. It's useful to remember that these are logical opposites because the opposite squares also have opposite distributed terms. So first, let's look at the A and the O sentence. In the A sentence, the subject's distributed, but the predicate isn't. In the O sentence, it's the opposite. The predicate's distributed, but the subject isn't. Likewise, if we look at the E and I sentences, in the E sentence, both terms are distributed, but in the I sentence, neither term is distributed. So now let's look at our three formal rules. Here's the first one. The middle term of our syllogism is distributed exactly once. We'll call that the middle term rule, or MTR. The second rule says that neither end term is distributed exactly once. End term is just a short, handy way of referring to the subject and predicate terms. So this rule says that neither the subject nor the predicate term is distributed exactly once. We'll call this our end term rule, ETR. The third rule doesn't make any reference to distribution. It simply says that the number of negative premises equals the number of negative conclusions. So if there's a negative premise, there has to be a negative conclusion. If all of the premises are affirmative, the conclusion also has to be affirmative. And if your syllogism has two negative premises, it can have at most one negative conclusion, so it would automatically violate the negative statements rule in SR. How do we use these rules? Well, a standard form categorical syllogism is valid if it satisfies all three formal rules. Another way of putting it is that a standard form categorical syllogism is invalid if it violates even one of these rules. Let's put these rules into practice. Here's our first problem. Premise 1, all microprocessors are silicon-based. Premise 2, some computing machines are not silicon-based. Conclusion, some computing machines are not microprocessors. The first thing we're going to do is put this syllogism into standard form, and we're going to identify the categorical form of each of the generalizations. So here we go. The first premise is an A sentence. All microprocessors, M's, are silicon-based things. SBTs. The second premise is an O sentence. Some computing machines, CMs, are not silicon-based things. The conclusion is an O sentence. Some CMs are not Ms. We also want to keep track of our subject, middle, and predicate terms. Because computing machines is the subject of the conclusion, it's the S term for this syllogism. Because silicon-based things appears once in each premise and not in the conclusion, it's our middle term. Microprocessors, Ms, is the predicate term of our conclusion. That makes it the predicate term of the syllogism. The next thing we want to do is mark all of the distributed terms. The subject of our A sentence is distributed, and the predicate of our two O sentences is also distributed. Let's see how this syllogism fares on our three formal rules. The middle term rule says that the middle term has to be distributed exactly once. So when we look at silicon-based things, it appears once in each premise, and it's distributed in one of those premises. So this syllogism satisfies the middle term rule. It's distributed exactly once. If we look at the two end terms, we'll take them one at a time. Computing machines, our subject term, is not distributed at all. Microprocessors, our predicate term, is distributed twice. Therefore, neither end term is distributed exactly once. This syllogism checks out. If we look at our premises, we have an A sentence and an O sentence. The O sentence is negative. The A sentence is affirmative. So we have one negative premise. The conclusion is also an O sentence. And that means that it has one negative conclusion. 1 equals 1, and so this syllogism satisfies the negative statements rule. Because it satisfies all three rules, this is a valid syllogism. Let's look at the next problem. Premise 1, all mammals bear live young. Premise 2, all mammals are hirsute. Therefore, the conclusion, all creatures that bear live young are hirsute. I'd like you to pause the video here, put this syllogism in standard form, identify the forms of the three categorical generalizations, and identify the subject, middle, and predicate terms. Hit pause here and resume when you've taken an attempt at that part of the process. Here's the syllogism in standard form. All mammals are creatures that bear live young. That's an A sentence. All mammals are hirsute things. That's an A sentence. Therefore, all creatures that bear live young are hirsute things. Another A sentence. Our subject, middle, and predicate terms are creatures that bear live young, mammals, and hirsute things. Where are our distributed terms, though? All three of these are A sentences, so therefore their subjects are the distributed terms. Now that we have this set up, let's apply our three rules and see how the syllogism does. The middle term rule says that the middle term has to be distributed exactly once. However, mammals is distributed twice, so this actually violates the middle term rule. Let's look at the end term rule. Neither end term is distributed exactly once. Let's check out the subject term first. Creatures that bear live young appears twice. It's distributed once. This violates the rule. Just to be complete, let's check out the predicate term, hirsute things. It appears twice and is not distributed at all. So actually the predicate term satisfies the end term rule, but we consider the rule violated because the subject term was distributed exactly once. Also, we note that all of the generalizations are affirmative, so we have no negative premises and we have no negative conclusions. 0 equals 0. And so this syllogism actually satisfies the negative statements rule. However, because it violated a rule, this syllogism is invalid. Let's look at a third problem. No tobacco farmers have lung cancer. Some lung cancer patients are smokers. Therefore, some smokers are not tobacco farmers. I'd like you to hit pause here, put this syllogism in standard form, label the generalizations, and identify the subject, middle, and predicate terms. Hit pause here and resume only after you've given it a try. Here's the argument in standard form. The first premise is an E sentence, no tobacco farmers are lung cancer patients. Second premise is an I sentence, some lung cancer patients are smokers. And the conclusion is an O sentence, some smokers are not tobacco farmers. The subject, middle, and predicate terms are smokers, lung cancer patients, and tobacco farmers. Where are our distributed terms? If you look at the first premise, it's an E sentence, so both terms are distributed. The second premise is an I sentence, so neither term is distributed. And the conclusion is an O sentence, so the predicate term is distributed. Let's see how they fare on the three formal rules. Why don't you try this independently? Hit pause here and decide whether this syllogism satisfies the three rules before resuming. Hit pause now and resume when you're ready. So the middle term here is lung cancer patients, and we can see that it is distributed exactly once. That means that the middle term rule is satisfied. The end terms, let's take a look at them. Smokers is not distributed at all. Therefore, it's not distributed exactly once. Tobacco farmers is distributed both times, so it's not distributed exactly once. The end term rule is satisfied. E is a negative premise, and I is an affirmative premise, and O is a negative conclusion. Therefore, we have one negative premise and one negative conclusion. 1 equals 1, and so the negative statements rule is satisfied, and this syllogism is valid. Let's look at a fourth problem. Some beautiful people are vain. All beautiful people are admired by others. Therefore, some vain people are admired by others. I'd like for you to pause the video, put this in standard form, identify the categorical forms of the generalizations, and identify the subject, middle, and predicate terms. Hit pause now and resume when you've taken a stab at all of those. This is the syllogism in standard form. The first premise is an I sentence, some beautiful people are vain people. The second premise is an A sentence, all beautiful people are people admired by others. The conclusion is an I sentence, some vain people are people admired by others. The subject, middle, and predicate terms are vain people, beautiful people, and people admired by others. Where are our distributed terms? The first premise is an I sentence, so neither of the terms is distributed. The second premise is an A sentence, so its subject term is distributed. And again, the conclusion is an I sentence, so neither term is distributed. Take a look at the three formal rules and determine whether or not this syllogism satisfies them all or violates any of them. Hit pause here and resume when you've given that a try. The middle term is beautiful people, and as we see, it's distributed in one of the two occurrences. That means it satisfies the middle term rule. The end term rule is pretty easy in this case. Neither end term is distributed at all. Vain people's not distributed at all. people admired by others is not distributed at all. So neither term is distributed exactly once, and we get the green light. All of these generalizations are affirmative, and that means there are no negative premises and no negative conclusions. So the negative statements rule checks out as well, and the syllogism is valid. Let's do one more problem. No hothouse tomatoes are expensive. All expensive things are worth the money, so no hothouse tomatoes are worth the money. I'd like for you to put this in standard form, identify the forms of the generalizations, then identify the subject, middle, and predicate terms. While you're at it, circle all the distributed terms. Go ahead and hit pause now. Resume the video when you're finished. Here's the argument in standard form. No hothouse tomatoes are expensive things. That's an E sentence. All expensive things are things worth the money. That's an A sentence. No hothouse tomatoes are things worth the money. That's another E sentence. Our subject, middle, and predicate terms are hothouse tomatoes, expensive things, and things worth the money. Where are our distributed terms? Both terms in our E sentence are distributed. The subject of our A sentence is distributed. And then once again, both terms of our conclusion, which is an E sentence, are distributed. What we want to do is make sure that this determine whether or not the syllogism satisfies our three formal rules. What I'd like you to do is hit pause now and determine whether this satisfies the three formal rules. When you're ready, resume the video. Let's look at the middle term rule first. Our middle term is expensive things, and as you see, it's distributed in both occurrences. That means it's not distributed exactly once, so the middle term rule is violated. Let's look at the end term rule. It says that neither end term is distributed exactly once. When we look at the subject term, that's right. It's not distributed exactly once. It's distributed twice. When we look at things worth the money, however, we see that it's distributed in the conclusion, but not in the second premise. That means it is distributed exactly once, but that violates the end term rule. Finally, when we look at the negative statements rule, we see that we have one negative premise, that's the E sentence, and we have one negative conclusion since it's also an E sentence. 1 equals 1. So this satisfies the negative statements rule. But because it violates even just one of the formal rules, the syllogism is invalid.